friends. I'm Christian Penoli. Welcome to Katas CNC tutorial. Numerical control technology as it is known today emerged in the mid 20th century. It can be traced to the year of 1952 US Air Force and the name of John Parson and the MIT in Cambridge, USA. It was not applied in production manufacturing until the early 1960s. The real boom came in the form of CNC around the year of 1972 and a decade later with the introduction of affordable microcomputers. The history and development of this fascinating technology has been well documented in many publications. Well, what is CNC? CNC stands for Computer Numerical Control and has been around since the early 1970s. Prior to this, it was called NC for Numerical Control. In the early 1970s, computers were introduced to these control, hence the name change. While people in most walks of life have never heard of this term, CNC has touched almost every form of manufacturing process in one way or another. If you will be working in manufacturing, it is likely that you will be dealing with CNC on a regular basis. How CNC machine works. As you might already have guessed, everything that an operator would be required to do with conventional machine tools is programmable with CNC machines. Once the machine is set up and running, a CNC machine is quite simple to keep running. In fact, CNC operator tends to get quite bored during lengthy productions run because there is so little to do. With some CNC machine, even the workpiece loading process has been automated. We don't mean to oversimplify here. CNC operators are commonly required to do other things related to the CNC operation like measuring workpiece and making adjustment to keep the CNC machine running good workpiece. Programmable functions, motion control. All CNC machine types share this commonality. They all have two or more programmable directions of motions called axis. An axis of motion can be linear along a straight line or rotary along a circular path. One of the first specifications that implies a CNC machine's complexity is how many axes it has. Generally speaking, the more axes, the more complex the machine. The axes of any CNC machine are required for the purpose of causing the motions needed for the manufacturing process. In the drilling example, these three axes would position the tool over the hole to be machined into axis and machine the hole with the third axis. Axes are named with letters. Common linear axis named are X, Y, and Z. Common rotary axis named are A, B, and C. In this whole operation, the BMC machine used and three axes. And in lathe machine, here are two axes, X and Z. Now programmable accessories. A CNC machine would not be very helpful if all it could only move the workpiece in two or more axes. Almost all CNC machines are programmable in several other ways. The specific CNC machine type has a lot to do with its appropriate programmable accessories. Again, any required function will be programmable on full down CNC machine tools. Here are some examples for one machine type. Machine centers. Machining center, automatic tool center. Most machining center can hold many tools in a tool magazine when required. The required tool can be automatically placed in the spindle for machining. Number 2, spindle speed and activation. The spindle speed in revolution per minute can be easily specified, and the spindle can be turned on in a forward or reverse direction. It can also, of course, be turned off. Number 3, coolant. Many machining operations require coolant for lubrication and cooling purpose. Coolant can be turned on and off from within the machining machine type. The CNC program. A CNC program is nothing more than another kind of instruction set. It's written in sentence-like format and the control will execute it in the sequentially order, step by step. A special series of CNC words are used to communicate what the machine is intended to do. CNC words begin with letter address like F for feet, S for spindle speed, and X, Y, and Z for axis motion. When placed together in a logical method, a group of CNC words make up a command that resembles a sentence. The CNC control. First, Central Process Unit (CPU). The CPU is the heart of a CNC system. It accepts the information stored in the memory as part program. This data is decoded and transformed into specific position, control, and velocity signals. It also observes the movement of the control axis or spindle, and whenever this does not match with the programmed values, a corrective action is taken. All the compensation required for machine acquires like lead screw, pitch error, tool wear out, backlash are calculated by CPU depending upon the corresponding inputs made available to the system. The system will be taken care of during the generation of control signals for the axis movement. Also, some basic safety checks are built into the system through this until and continuous necessary corrective actions will be provided by CPU unit. Whenever the situation goes beyond control of the CPU, it takes the final action of shutting down the system and in the turn of the machine. Second, servo control unit. The decoded position and velocity control signals generated by the CPU for the axis movement from the input to the servo control unit. This unit in turn generates suitable signals as command values. The command values are converted by the servo drive units which are interfaced with the axis and the spindle motors. The servo control unit receives the position feedback signals for the actual movement of the machine tool axis from the feedback devices like linear scales, rotary encoded coders, revolvers, etc. Number third, operator control panel. The operator control panel provides the user interface to facilitate a two two-way communication between the user, CNC system, and the machine tool. This consists of two parts are video display unit and keyboard. Number fourth, CNC control. Fourth, machine control panels. It is the direct interface between the operator and the NC system, enable, enabling the operations of the machine through the CNC system during program execution. The CNC control the axis, the motion, spindle function, or tool function on a machine tool depending upon the part program stored in the memory. Prior to the starting of the machining process, machine should first be prepared with some specifics takes like establishing a correct reference point, loading the system memory with the required part program, loading and checking of tool offsets, zero offset, etc. The CNC control program, number fifth part, programmable logic controller PLC. PLC were basically as replacement for hardware relay control panels. They were basically introduced at replacement for hardwired relay panels. They developed to be reprogrammed without hardware changes when requirements were already and thus are reusable. PLC are now available with increased functions, more memory and larger input-output capabilities. In the CPU, all the decisions are made relative to controlling a machine or a process. The CPU receives input data, performs logical decisions based upon stored program and drives the output connection to a computer for hierarchical control are done through CPU. A CNC system may be characterized in terms of three major elements: hardware, software, information. Number six, hardware. Hardware include the microprocessor that affect control system functions and peripheral device for data communication, machine tool interfacing and machine tool status monitoring. Number seven, software. Software includes the programs that are executed by the system, microprocessors, and various type of software associated with CNC. Number eight, informations. Information regarding the dynamic characteristics of the machine and many other information pertaining to the process. Types of CNC machines: drilling machines, lathe turning center, milling machine center, machining center, turret press and punching machine, wire cut electro discharge machine, EDM electro discharge machine, grinding machines, laser cutting machines, water jet cutting machines, electro discharge machines, coordinate machine, measuring machine, industrial robots. These are some machines: CNC drilling machine, CNC lathe machine, CNC milling machine or BMC, CNC wire cut and ADM machines. Advantage of CNC machine: highly repeatability and precision is aircraft parts. Volume of production is very high. Complex contours surfaces need to be machined. Example, turbines. Flexibility in job change, automatic tool machine, tool settings, less scrap. Safer, higher productivity, better quality, less paperwork, faster prototype productions, reduction in lead times, easier to program, easy storage of existing programs, avoids human error, usually generate closer tolerances than manual machines, program editing at the machine tool, control system upgrade possible. Limitations of CNC machine, costly setup, skilled operators, computer programming knowledge required, maintenance is difficult, machines have to be installed in air conditioned places. Here are some applications for CNC machines. Uh, Aerospace equipments, automobile parts, complex shapes, electronic industries uses CNC, example printed circuit board. Electrical industries uses CNC, example coil winding. For small to medium batch quantity, where the setups are very large, where the tool storage is a problem, where much metal needs to be removed, when the part geometry is so complex, the operations are very complex, for parts subjected to regularly design changes, when the inspection is required 100%. Preparatory commands G code. Fanuc G code list lathe for lathe. G code 00 rapid traverse. G01 linear interpolation. G02 circular interpolation clockwise direction. G03 circular interpolation counterclockwise direction, G04 dwell time, G09 exact stop, G10 programmable data input, G20 input in inch, G21 input in mm, G22 stored stock checked function on, G23 stored stock checked function off, G27 reference position return check, G28 return reference position, G40 tool nose radius compensation cancel. G41 tool nose radius compensation cancel left, G42 tool nose radius compensation cancel right, G70 finish machining cycle, G72 facing cycle, G73 pattern repeating cycle, G74 park drilling cycle, G75 grooving cycle, G76 threading cycle, G90 turning cycle and absolute coordinate, G91 increment command, G94 feet per minute, G95 feet per revolution, G96 constant surface speed control, G97 constant surface speed control cancel. For milling machine, G00 rapid traverse, G01 linear interpolation, G02 circular interpolation, CW, G03 circular interpolation, CCW counterclockwise direction, G04 dwell time, G17 XY plane selection, G18 YZ plane selection, G19 ZX plane selection, G28 return to reference position, G30 return to second, third, fourth reference position, G40 cutter compensation cancel, G41 cutter compensation left, G42 cutter compensation right, G43 tool length compensation positive direction, G44 tool length compensation negative direction, G49 tool length compensation cancel. Next G54 workpiece coordinate system first selection, G55 workpiece coordinate system second selection, G56 workpiece coordinate system third selection, G57 57 workpiece coordinate system fourth selection, G58 workpiece coordinate system, 5th selection. G59 workpiece coordinate system, 6th selection. G80 canned cycle, cancel. G81 drilling cycle, spot boring cycle. G82 drilling cycle and counter boring cycle. G83 pick drilling cycle. G84 taping cycle. G85 boring cycle. G86 boring cycle with dwell. G90 absolute command. G91 increment command. G92 setting for work coordinate system. G98 return to initial point in canned cycle. Miscellaneous function of M code for lathe machine. M00 program stop, M01 optional program stop, M02 end of program, M03 spindle start forward, clockwise direction, M04 spindle start reverse, counterclockwise direction, M05 spindle stop, M08 coolant on, M09 coolant off, M30 end of program reset, M98 subprogram call, M99 end of subprogram. For BMC machine, milling machine, M00 program stop, M01 optional program stop, M02 end of program, M03 spindle start forward, clockwise direction, M04 spindle start reverse, counterclockwise direction, M05 spindle stop, M06 tool change, M07 coolant through spindle, M08 coolant on flood coolant, M09 coolant off, M19 spindle orientation, M30 end of the program reset, M98 subprogram call, M99 end of the subprogram. Fanuc control machine start. How to start software? Uh, Open Swansoft CNC simulation software. Then select Fanuc OIT, operation turning, Mac, encryption and run. Here is the interface of lathe machine. NC control panel, then program panel, write program, then operation panel, standard toolbar, view toolbar, menu bar, turret, tally stop and head stop, and a spindle, chuck, standard toolbar, the new NC code, set up new NC file, file open save file such as NC file, then file save file such as NC file, save as, open file, parameter setting, set machine parameter, and tool management, cutter library management, display mode, pattern workpiece display, workpiece setting, choose size and coordinate of workpiece, then machine door, open and close machine door, clamp position, in out clamp position. Step in programming, study the parts drawing. After that, select the machine, select the tools, decide the work holding method, decide operation sequence, decide the cutting parameters, write the NC program, estimate the cycle time, make setup sheet and list of tools, enter the program at the machine, check and correct the program, and after that start machine. This is the single block program. single block, program number, then block sequence, N10, G code and M code, world, X and Z direction, feed rate F 100, in micron, speed S 2000, spindle speed, tool code T0101 uh, tool number, and this sign is end of the block. Here is the turning and fillet drawing. Turning cycle G90 and G02 circular interpolation clockwise direction, G03 circular interpolation counterclockwise direction. Now this is the drawing and implement for raw material for the manufacturing is job. Next step to make program and run lathe machine. First open software on emergency button and program protect button. Select MDI mode to run spindle. Workpiece setting, open tool management, tool settings, offset setting, make program and run program. Here is the program of a job O0072, the program number, N10 sequence number of the program, M03 S2000 machine start, spindle start, and SP2000 of a spindle, T0100 tool change, G00 rapid action movement, X 100 Z2 T0101 F feed rate 100, G90 turning cycle, X95 diameter of workpiece, the diameter of job, Z minus 110 direction, minus 110 direction here from here. This X90 Z minus 110 same continue X85 Z minus 110 X80 Z minus 110 X75 from this Z minus 50 X70 Z minus 50 X60 Z minus 50 X60 Z minus 50, then G00 X100 Z100 back position of tool, G00 X40 Z0, G03 X60 Z minus 10 R10 fillet radius, G03 code counterclockwise direction, and G00 X60 Z minus 50 X60 Z minus 50. Here tool is in this position, X80 Z minus 110, sorry, G02 X80 Z minus 60 R10. Now G00 X80 Z minus 110 and G02 X100 Z minus 110 R10. R10 radius, fillet radius 10, G02 clockwise direction. Now G00 X100 Z100 tool position and M02 stop spindle, M30 stop program. Here is the CNC machine milling machine interface. Standard toolbar, view toolbar, menu bar, then tool, magazine, numerical control panel is control panel, the program panel, operation panel, the bed, workpiece, drawer. Here is the milling machine program, drilling cycle G81, G96, M03, S2000, M06, T1, tool change, G00, G90, X0, Z5, tool position, G54, offsets setting port X minus 60 by minus 60, Z5. This is the position of tool. And G99, G81, 81 is the code of drilling cycle, X60, Y minus 60, Z minus 20, minus 20 drill hole depth, R2 for use for R for drilling cycle, F feed rate 100, and this is the program of milling machine. Now CNC machine and safety. Safety glasses must be worn at all time in work areas. Sturdy footwears must be worn at all times in work areas. Rings and jewelries must not be worn. Long and loose hair must be contained. Close fitting protective clothing must be worn. Gloves must not be worn when using this machine. Environmental control for CNC machine. Well air circulations, working temperature should be within control limits. Space should not be congested but should be quite open. Electrical power supply should be regulated. There should be proper disposal point of for scrap. There should not be presence of noisy source near the machine. There should not be presence of harmful chemicals near to the machine. Proper lighting to the system. The machine should be protected from the moisture. There should not be presence of vibrating source near to the machine. Power supply should be regulated. Thank you.